The universe is huge, unimaginably huge. In fact, it's so big, the human brain cannot correspond its massive size. We simply haven't evolved to ever need to worry about numbers so big. But despite its huge size, the universe is getting bigger. Not only is it growing in size, it's accelerating in its own growth. Opposite to how when a person grows up, their height changes more slowly, when the universe grows up, its size changes more quickly. But this raises a question. If gravity pulls everything inwards to a point of larger mass, why are we accelerating outwards? There's plenty of mass in the universe. In fact, all mass is in the universe. So why does the universe accelerate away from it rather than towards it? As you would expect according to the laws of gravity. This paradox is known as the Bentley Paradox. The theory of gravity was discovered in 1687 by a man named Isaac Newton, who you probably already know about. His theory relied on a lot of maths, which I can't explain to you with absolute certainty, but I can say this. There were two very important parts of this theory. Firstly, an object that has more mass than another object will attract the less massive object to itself. And secondly, throughout the universe, this gravitational pull was decided by this equation. That big G is the gravitational constant, and as the name implies, it is constant throughout the observable universe. What does that mean? Well, if I am on a planet 1 million light years from Earth, then the same laws of gravity apply to me on that planet as they do on Earth. That does not mean the acceleration of gravity is 9.81 meters per second squared as it is on planet Earth, but rather its acceleration is dependent on that planet's mass and that planet's radius. Larger mass than Earth, higher acceleration, greater force caused by gravity on an object. Smaller mass than Earth, lower acceleration, smaller force caused by gravity on an object. Well, knowing now that more massive things attract less massive things, and that all mass exists within the observable universe, surely rather than expansion, the universe should experience a big crunch, with galaxies coming into collision with other galaxies. Back when Isaac first made his theory, the human species didn't know the universe was expanding, but they did know it wasn't crunching either. So, Richard Bentley questioned Isaac on the Big Crunch theorem, and Isaac's solution was this: that God prevented the collapse by making constant, minute corrections to the universe. Although it solved the problem at the time, it didn't exactly solve it scientifically, so the question still remained. To begin to theorize why the universe might be expanding at an accelerated rate, it's important to understand what its expansion actually looks like. The universe expansion is best compared to a balloon in my opinion. Here is the universe 10 billion years ago. It's still huge, but smaller than it is today. And here's the universe in the present time. The X's mark a galaxy, for example. As you can see, these galaxies are now further away from one another in scenario 2. This is because it's not like in the universe's expansion, it is discovering new areas and planets like you would in a video game or something, but rather the underlying fabric of space is stretching out. Just like in a balloon, how the rubber expands when expanding, the underlying fabric of space in the universe expands. With that knowledge, we can start to talk about what space actually is. If you move your hand through the air, it may feel like you're moving into nothing, but actually there's tiny air particles, which are very minutely slowing your arm movement down. In simplified terms, this is because the kinetic energy you are giving your arm is being converted to thermal energy upon contact with the air particles. And since energy is conserved, the kinetic energy in your arm is lessened. And hence, through this equation, the speed of your arm is lessened. Now envision empty space. We know, for a fact, there is no air in space. In fact, there's nothing that can reduce speed. But what if there was an energy present in every part of space that we can't measure at all? Meet dark energy. Einstein, world-famous physicist who was coincidentally mentioned in my last video, came up with a theory that empty space can possess its own energy. As more space comes into existence due to the expansion of the universe, more energy comes into existence. This energy adds to the energy of the universe, and just like if I were to heat up the air in a balloon, adding energy to that system, that balloon expands. And hence, it makes logical sense the universe would be no different. Another theory surrounding dark energy is that dark energy is a new kind of dynamical energy fluid or field that we do not yet understand. This energy would fill all of empty space as before, but would act in an opposite manner to how matter would normally interact with an expanding system. This is definitely a mysterious solution, and probably the most far-fetched one. For this to be true, energy as we understand it would basically have to be turned on its head. A final possibility is that Einstein's theory of gravity is incorrect.
Possible.
I say Einstein here, by the way, because he was the first one to describe gravity as an acceleration. Isaac Newton was not. Possibly within Einstein and Isaac's theories, there is something being missed out. Clearly, we don't know everything about gravity, because if we did, its laws would apply to dark energy and matter alike. Again, this solution is all just theory. At this point, and in NASA's words, the solution to these problems can be solved with more data and better data. Anyways, that was Bentley's Paradox, and some theories to the accelerating expansion of the universe. I just wanted to say a huge thank you to my first ever Patreon, Brad. I don't see this channel being monetized in the near future at all, so your valiant patronage is appreciated. Dark matter and energy is very interesting, and if you want to know more, there are a few sources in the description that I personally used. Anyways, hope you had a great New Year's celebration, and that Bentley's Paradox wasn't too badly described.